so this is your homework, Unit 2 Inequalities homework. Let me pull up the, this is due, oops. This is due a week from today. So today is Friday, so this would be due Friday, October 1st. Due Friday, October 1. Good? That's the due date. Write that in there. Below your name. Then we're going to talk about these things. There's inequality representation, interval representation, and graphical representation. We're going to talk about what those are. So you guys are good to go on this. So go ahead and go in here, because usually, there you go. Should just kind of write it out there. So this one, this right here, what does that mean? It definitely means less than. Which one's less than which? X is less than 2. If you are unsure how to tell which direction it goes, because it's going to come up pretty often. Yeah, I use the fish actually. I like to think of a little fish, or a big fish. Here's the fish, and he ate the smaller guy, because when you're a fish and you're eating other fish, the smaller one's easier to catch. So the X is easier to catch. He already ate it. It's in his stomach. He's going after the bigger one, 2. So 2 is bigger than X. Good? So if you're not sure, draw your fish. That way you know that, okay, he ate that one, that's the little one. That one's harder to catch is the bigger one. So the 2 is bigger. How would I write that X is less than or equal to 2? Or equal to.
Oh, you put the line underneath.
Yeah. Yeah, so it incorporates both. So you say X is not just less than 2, but it's also equal to 2. Because our equal sign is 2 of those lines, right? It would be equal, so we kind of combined them and gave it part of the equal sign. So it's X is less than or equal to 2. So that means it's either less than 2 or it could also be equal to 2. So that's the inequality representation of that. It's just like that. Let me see if there's any other comments I usually give you guys. Right, so it's just sort of a combination of taking the less than and the equal to. So you also see that. That also means less than or equal to. If people don't have, if you're typing stuff in, then that's the notation. But you guys are going to be all handwriting your test. There's going to be typing stuff in, so you should be all good. It also can be written like this. Here's X. What's bigger than X? 2 is bigger than X. Are you guys kind of with me? So here I'm X. Am I less than 2 or am I bigger than 2? Less than 2. Does everyone understand that? That's what we're writing. We're writing X is less than or equal to 2. So I'm less than 2 or maybe equal to it. So I would write it like this. I am less than or equal to 2. What's on the other side of me? So here's 2. I'm here. I'm less than 2 or maybe equal to 2. But what am I bigger than? What's way, way, way over there? What's the number that's way, 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 way over there?
-10.
Negative infinity. Does that kind of make sense? I mean, negative 10 is over there too.
Right.
But like, if you keep going, negative infinity. So it's sort of this invisible negative infinity on this side. So you could also write it like that. Negative infinity, it's like 2, it's like a sideways 8. Right? Okay, good. So that's another way of writing it. Now, interval notation does this. Interval notation, if I'm like this, I grab what's on the smaller side, I'm less than, negative infinity, and then I write what I'm greater than, what's on my smaller side and what's on my bigger side, what I'm less than, and I put a comma between them. So interval representation is pretty straightforward. You take what's on this side, negative infinity, take what's on that side, 2, put a comma between them, and then you put parentheses, either parentheses or you either put these guys around them or these guys around them. This is if you cannot equal it. You can never, ever, ever equal a negative infinity. Ever. You can't. It's infinite. So I put this around it. Can I equal 2? Am I allowed to equal 2 in this situation? Am I allowed to equal 2 in this situation?
Yes.
Yes. So that would have a square bracket around it.
And so the parentheses are, if it cannot equal,
Yep.
and the.
Can
square-
equal. Can equal.
okay.
So maybe you want to write this stuff down, right? These would be great notes to write down somewhere. On the back of that page if you want, or the bottom of that page, either one, because you're going to be using that sheet. But yeah, so you guys should be taking notes. It's a lot easier to remember stuff in this class if you take notes in it. Good? So again, also this one is can equal. That one there is can't equal. Right? Everyone kind of on board with these ones so far? Good. Now we're going to have graphical representation. So graphical representation is when you graph it. So if you look on your handout, you have your homework, you have graphical representation in there. Let me undo that. I'm going to change this myself. Okay, good. So with graphical representation, you always want to anchor yourself to something. So I'm graphing less than 2, so I'm going to give myself a marker like 0. Where's 2? On this side or this side?
Right.
It's over here somewhere, yeah? So marking where 2 is. Pick a spot. 2's over here somewhere. Now I am less than 2. What area is less than 2? This side or that side? If you're not sure, pick a number. Is 0 less than 2?
Yeah.
Yeah, so that's the side I want. Does that kind of make sense? So I want this part here. Now then comes the question of, can I equal 2? Am I allowed to equal 2 or not?
Yes.
Yes, I can equal 2. So how would I graph x is 2? How would I just graph 2 if I were graphing 2? How would I make graph 2? If I say graph 2 on the number line, what would you do? You do a dot. You do a circle, right? A dot right at 2. Does that everyone kind of follow me? So you guys would do just a dot right at 2.
Oh, at 2, not negative 2?
No, I'm not less than negative 2. I'm less than 2, or equal to 2, right? Negative 2 doesn't come in the. Negative 2 has nothing to do with this at all. I'm all talking about 2s
Oh,
here.
I'm in the wrong one.
Yeah, you're not doing your problem. You're doing.
Oh.
I'm doing practice ones.
Oh, okay, you're doing.
I'm
a different
showing
one.
you guys how to do stuff. I'm instructing you. Okay, so this is that one. So this is equals to 2 or less than 2. If I were to go not equal to 2, then I'd have an open circle saying I'm not touching you. I think of it like a little kid who goes next to their brother in the car, like I'm not touching you. They get like really close to their face, right? So it's like a circle around it, so you're not touching it. So this would be not equal to. Does everyone kind of understand? Whereas the whole circle is
Oh, like an.
equals. Are you guys seeing the difference between those two? Okay, now there's a second way you can write this if you want. It's your option. But some people do it this way. They have their 0, they have their 2, and instead of doing the circle, they do the same thing. They use this guy here, and they would do the square bracket. You can also do that. So some people do the circle and some people do the square bracket. They mean the same thing. These both mean you can equal to, and you're less than. These are equivalent. If you couldn't equal 2, you would do the rounded bracket. So you can either do brackets, the bracket, either the rounded or square bracket, or you can do the open circle, closed circle. I don't care which one you do. Doesn't matter. Okay, let's do another example. X is greater than 3. How would that look? I have my X, it's greater than 3. Which way does it go? Does the mouth go towards the X or away from the X? Towards the X, because X is bigger. Right, you're eating the bigger one. So, towards the X is greater than 3. Oh, incidentally, this is exactly the same thing as 3 is less than X. They mean the same thing. Either way, X is bigger. You can write them either way, doesn't matter. Good? Everybody on board with that? Both of those things are the same thing. They're equivalent. Doesn't matter which way you write it. Okay, so my inequality representation. Okay, so X is bigger than 3. So 3 is less than X. What's on the other side? So really this is sort of like saying, here's X. 3 is smaller than it. What's bigger than X then? What's on the other side of X? So it's way, I'm X. I'm bigger than 3. Ha, you're puny 3, you're over there. What's over here? What's way over there? Infinity.
Okay.
Does that make sense?
Yes.
Infinity's bigger than me. So really, it's really like that. So it means on the smaller side is 3. On the bigger side of me is infinity. Can I equal 3? Can 3 be equal to me?
No.
No, so it's going to be a rounded bracket. I can never ever equal infinity, so it's always going to be a rounded bracket. The infinities. So again, this is inequality. This is I'm sorry. This is interval representation. My bad. I should move this down. It should be down here. This is interval representation. Not to confuse you. So this right here is inequality representation. You can write it either any one of those 3 ways is fine. I don't care. Any one of those is okay. You can write it X is greater than 3, 3 is less than X, or X is between 3 and infinity. All good. All of those are all good. Oh, except I forgot my parentheses around the interval notation. Can never, ever equal infinity, so there's a rounded bracket there. Questions so far? Good? You can totally take pictures of this too. It's also available. It will be available. I'll post it up on Canvas under board PDFs. Graphical representation. Aha. I'll give you those 2 options. So you got to mark in 3 is what I care about. So I put in my 3. Put in something else to anchor yourself. So I'll put in 0. How does it sound, right? So 0 should be on the left or the right of 3? Left. Good. So I'm going to be greater than 3. That means that I am, if I'm greater than 3, am I on this side of 3 or this side of 3?
The right.
Yep, this side. Can I equal 3?
No.
No, I cannot equal 3. So I'm going to have a open circle where 3 is. I'm not touching it. I'm not touching you. And then off that way. Good?
Mm-hmm.
Everybody on board? You could also graph it. This way. Open parentheses. Open parentheses. Yeah, the rounded parentheses, sorry, I should say it. Rounded parentheses, and then that one. Okay. So it'd be like this on this side. On this side, it would be like that, because it's the smaller side. It's this way, right? And same with the square brackets, they go like that. If you don't want to worry about which direction the brackets go, you can just use the open circle and closed circle. Which one did I do? Did I do less than? Yeah, I did. And then you're also gonna hit some places, if you look at the bottom of your page, you're gonna hit some of these other guys where it's like, X is less than, so if you look at like the second to bottom one, number 8 on your handout, and we'll look at your handout. Number 8, you have this one thing or another thing. So here, I'm not doing your problem, I'm doing a different problem. I'm going to do X is less than -1 or X is greater than or equal to 2. So inequality representation would be, how do I write X is less than -1? I'd go X is, well, less than -1. That's pretty straightforward. And then you have the word, you have or. This is a symbol for or, like that.
Oh, it's not union?
It's union, yeah,
Oh.
union. Or is union,
Oh.
right? Because if I like carrots or potatoes, that means I like both of them. It's a union. I'm happy if you give me carrots or potatoes. Okay, union with X is greater than or equal to 2. Good? Now, let's see. Interval representation. This one gets a little bit messy. Let's see. X is less than -1. So I'm going to write in a little visible, but it's greater than -infinity. So this is going to be -infinity to -1. Can I equal -1? No, so it's going to be what? Square or rounded? Rounded. Or, see, I'm greater than 2. I'm greater than 2, so it goes X is greater than or equal to 2. But it means that I'm less than what?
No, infinity.
Yeah, I'm greater than, so here I am, I'm bigger than 2. So here's me, there's 2, I beat 2, I'm bigger than 2, but I'm less than infinity. So, are you guys kind of following with me? You got to kind of put yourself in the spot. You're X. I'm bigger than 2. So that means 2's over here. On the other side of me is infinity. So I'm larger than 2. I'm less than infinity, positive infinity. And then that helps me go straight into this interval representation. I've got 2 on this side. Oops, I did that wrong. I've got 2 on this side, comma, infinity on that side. Can I equal 2?
Yeah.
Yes, so then it's going to be what? A square bracket. Everybody on board with that part? And then what about infinity? Can I ever equal infinity? No, you can never equal infinity, so it's going to be a rounded bracket. Take notes if you need to. See a lot of people taking notes, especially people who are understanding this or taking notes, because that means that they're trying to get it down so they remember it for your homework. Yeah. Graphical representation. Okay, so the ors are going to have a couple of things here. Let's see, or. I'm just going to do one because it's complicated. Let's see, I've got 0 here. I have -1 comes into play, and I've got 2 somewhere over here. All right, so, whoops. Yeah, I know it's kind of neat. Okay, so can I, let's see, I'm from a -1 to infinity. So -1 to infinity, or negative infinity. Can I touch -1?
No.
Nope, so I'm going to have a open circle there. I'm not touching you. Open circle. And then I also have 2 to positive infinity. Right? So I'm not this way. And this means both of them. So this one or this one. Either one's fine. Now, can I touch 2?
Yes.
Yes, so it's going to be a closed circle. Good? Everybody with me on this part? Okay, then let's talk about what some of these things mean. I'm going to give you my or and this. Okay, so or. How do I know what or means? Here's a symbol for or. Like that. I like to think of or as a guy opening his arms up and saying, I take everybody. You're welcome, all people are welcome, I take everybody. That's the or. What's the other word for it? You said it before?
Union.
Union.
So in the homework, it's a capital U or a lowercase u or something?
A capital, you can think of it like a capital U,
Yeah.
right? Like this, right? That's a symbol for it. And this is how it looks graphically. It's everybody. It's that group and that group. It's all of you. That's the or. That's different than and. Why are you guys not taking notes on this? This is big stuff here. All right, so the and is like this. Like that. That's a symbol for and. I like to think of it as a cowboy. He's got one leg in A, he's got one leg in B, he's in both of them. So, here's my little cowboy. He's got one leg in each one of them. Does that kind of make sense? This is and. This is also known as the intersection. Okay. So that's why it's important to kind of delineate these, because people get them mixed up all the time. They keep wanting to think that, keep thinking that or, that this means and, because it means both. Or really means both, the union. And is actually a little more restrictive. It means you have to be in both. If I'm and, then I'm the intersection. You have to be in both of them. So and is actually a really small amount. And is really only, if I graph it, and is just that little bit there.
Oh,
Does that, you guys kind of follow me? I'll make it darker. Versus this is the whole thing. Good? So this one, or like we just saw, you can either be, you could be this one or that one. So you include everything. The ors, you include everything. The ands, you have to be in both. So your back part talks about some ands, I think. That sheet, does it have any ands? Nope, it doesn't have any ands. We didn't do any ands with you guys. Oh wait, we do have an and. We have a couple ands in the middle. Right, so that, like number 5 is an and. Because you're between stuff. You're greater than -4 and you're less than 5 at the same time. So it's just that little bit in between. But you don't complicate, you don't have to complicate things with that. Here, I'll give you one. I'll try to put it into here, so I have it next time. Negative 2 is less than or equal to x is greater than, sorry, it's less than 3. We'll do that. So first I'll rewrite it, how you would see it on yours. It'd be -2 is less than or equal to x, which is less than 3. So if you get this one, it's really, actually, it's the easiest one of all. This is the interval notation, right? What's on my left side? -2. What's on my right side? 3. So for interval notation, -2, comma 3. Can I equal 2?
Yes.
Yes, so it's going to be a square bracket. Can I equal 3? No, so it's going to be a
Parentheses.
rounded bracket. Good? Or, yeah, parentheses. All right, and then down here, you just gotta punch in, well, here's 0, just to kind of give myself an anchor. Here's -2, and 3 is over there. And I am from 2 to 3. Can I equal -2? So I'm from -2 to 3. Can I equal -2? Yes, so a solid circle there. Can I equal 3? No, so an empty circle there. Open circle there. Good. So it's really straightforward. If you're given this part, you should be able to say, oh, look, it's just from -2 to 3. And then I can equal -2. I can equal 3, square bracket, rounded bracket. And then from there, I bump up to the next one and just put x between them. So getting between these three should actually be easier than it seems.
Is there any instances where you have to use the intersection symbol?
No. You will not have any instances where you need to use the intersection symbol. Yeah. Thank you for asking that. Great. Perfect.
So what does the, like on number 3, the arrow that stops on line 5?
Oh, okay, so yeah, I want to take a look at number 3. Take a look at number 3. Really? This guy here? Really, that really goes on and on forever.
Oh,
It
it's
doesn't
not
actually
stopping on
stop.
top.
It really means just keep going on and on forever.
Oh,
Yeah. So yes, so thank you for pointing that out. It does not actually stop there, it just keeps going. So when you see that arrow, that means just keep going. And they were just lazy, they didn't put it all the way to the end.
oh, okay.
Does that make sense? So this one really goes to the end. They're just lazy.
So that's infinite, the negative infinity.
Yeah,
Okay,
yeah, they really should go all the way.
okay.
Good? Everyone on board with that part? Thank you so much for asking that. Nice. It's good to have. I'm glad you guys are really great. I really appreciate all the questions you asked because that hits all these little spots that I should be bringing up or checking to see if I'm correct. Because it brings up all these little things that, to make sure that we're clear for everybody. And I think you guys the whole class will benefit from that. I think that should make things a lot smoother for all. Okay, good. So again, this is due a week from today.
It's nice to know that the creators of this have the patience of an elementary school teacher.
What was that?
It's nice to know they have the energy of an elementary school teacher.
Yeah, when they did these?
Yeah.
Yeah, I know they left out a couple things here and there. No one's perfect. Okay, so next, we're going to do introduction to functions. So pass these out. Pass those out.
What do you want us to turn to this one?
Today's, oh, right, so I'm going to try to get you guys going, and that'll be in a minute. I'll have you guys pass those in a minute, but I need to grab the sheet that I didn't grab before. So,
The packet or just the paper?
just the paper. So hold on to those for about another half an hour, and then I'll work with those in probably about 45 minutes. Okay, good. So we're going to hop into this one, definition of a function. Let me just check this and see how far I can go with this. Where the hell are these spots? Okay. So first off, let's get a reader. Fox, go ahead and read for me.
Definition of function. A function describes how the value of one quantity depends on the value of another. A function can be represented by a table of numbers, words, a graph, or a formula. In everyday language, a function expresses a notation of dependence, where the value of one quantity, outcome, depends on the value input of another. Specifically in math, the definition of a function is
Perfect, thank you. The definition of a function is if for every value of the first quantity, in other words, your input, your x, there's exactly one value of the second quantity, the output, your y, then the second quantity is a function of the first. So in other words, this, if I put something in here, an x in here, and I only get one answer, that's a function. But if I put something in here and I could get two possible different outputs, I'm not sure what I'm going to get, that's not a function. So a function should always know you're only going to get one thing if you put it in. You might not, you won't get two answers. And we're going to go through some examples of that. So don't worry, it'll become clear in as we kind of go through this. We're going to skip the machine part, 'cause that's something like that. When two items or quantities are related, but not in a functional way, it's called a relation. So when an input produces or is paired with more than one output, it's a relation. So that's either things are going to be a function, in other words, every input has only one output, or a relation where there could be an input that has more than one output. So we're going to take a look at some of these kind of step by step. Okay, so domain. So maybe below domain you might want to write input. Everybody write input below here. And then range, that's your output. Write down output there. So, let's go through the first one. My input is all members in a family. And then what we're going to do is give each person's height. So my range is all positive numbers. It could be any, right, and height could be any positive number. So here, let me ask you. If you put in members of your family, will you only get one answer for their current height right now?
yes.
Yes. All of us, I only have one height right now. I don't have two heights. My height is my height. Does everyone kind of follow me? So is this a function or not a function, or a relation? It's a function. You only get one answer. So everyone following me? If I put in my name, it's going to spit out just one answer, my height. This is a function. Why? Each person has only one height. Good? Okay, next. All the instructors at LPC. And then they're going to spit out all that instructor's classes. Or each instructor's classes. So it could be all classes at LPC. Alright, so if you throw me in and you find all the classes I teach at LPC, are you going to get only one answer? No, I teach 4 classes. So it could be any one of those. Do you guys follow me? So is this a function? No. Because if you put somebody in, you might get more than one answer. It's more than one possible answer you might get. So this is not a function. Not function. Because each teacher can teach more than one class. Sorry, kind of use extra space there. All right. Let's look at the next one. Radius of a circle. So if you throw in the radius of a circle, it wants you to find the circumference of that circle. The output, it could be any positive number. If I throw in a radius of a circle, will there only be one circumference for that radius? Yes. The formula for a circumference of a circle is 2 times the radius times pi. So if I throw in a radian, r, this is a fixed number, that's a fixed number, I'm just going to multiply it by that, and I'm only going to get one answer. If you say, what's the circumference of a circle with a radius of 3, there's only one answer for that. It's not like, well, it could be this or that. No, there's only one answer. So is this a function or not a function? Function. Because each radius has only one circumference. Okay, good. Everyone feeling okay with this so far? We're going through this, hopefully, like, kind of step by step to kind of get you guys comfortable with the concepts. All right, so we're going to take a look at the bottom part of the page. What ordered pair could you add to this set of ordered pairs to make it not a function? So let's just look at number 4. What ordered pair can I add to this set of ordered pairs to make it not a function? So 1, my input of 1 has an output of 2. Input of 4